In this video, we shall be discussing on moment generating function, and we'll be solving the equation on moment generating function. This time, we are given the moment generating function to be this, and we are asked to find the first and second moment of x and the variance of x. And if you watch at this distribution or this PDF is looking like a Poisson distribution. Now, how do we go about this? Solution. For more on this topic, we need to subscribe to this channel. You should note that the first moment, which is the mean, is equal to the moment generating function of nxt at t is equal to 0. So the mean, which is the first moment, is just the first differential at t is equal to 0. Also, the second moment is the second derivative of the given period at t is equal to 0. We should also note, after this, we come to the variance. So now, if we are given n xt to be equal to exponential 3 et minus 1. So for me to do this, for me to find the first differential, we employ what is called the function of a function method of differentiation. So what do we need to do? The first thing we do is say let u be equal to 3 et minus 1. So that it will be very easy for we to differentiate. And y will now be equal to exponential raised to the power of u. So it then means from that function of the function, we can write it to be the y all over the t is equal to the y all over the u multiplied by the u all over the t. So this becomes our first moment. This becomes our first moment. So if we differentiate this first, let's say the y all over the y all over the u will give us exponential u. Because if you differentiate an exponential function, you get that same function. Now, we also say the u all over the t. We are differentiating with respect to t. You get 3 exponential t. Of course, 3 multiplied by negative 1. If you differentiate negative 3, you get 0. If you differentiate 3, you get 0. So we have this. So we can just write our first moment to be equal to our first moment will be equal to the y all over the u multiplied by the u all over the t, which is equal to the y all over the u. We have the y all over the u to be e raised to the power of u multiplied by the u all over the t is 3 exponential t. Now, this is same our first derivative. We should also know that we say but our u, which is this, is equal to 3 et minus 1. 3 et minus 1. So all we need is to substitute what we have as our u into this. Let us see what we get. So we'll move over to this side of the board to do that. We'll have to substitute this u into this. So we'll have to delete this part of the board. We take this off. For more on this topic, You need to subscribe to this channel. You have to find the first and second moments of u. Then you will find the variance. So what do we do? Now we write this properly. We say n, the fourth derivative will give us exponential. Substituting this into u, we have 3 et minus 1 multiplied by 3 et multiplied by 3 et. So this is our first derivative. Now, for we to get the mean, which is the first moment, we say at t equal to 0. That means whenever we see t, we see 0. At t is equal to 0, it give us the mean, which is equal to our first moment, which is equal to exponential 3 exponential 0 minus 1 multiplied by 3 exponential 0. It then means that our expected value of x is equal to exponential. Of course, this will give us 0. Anything raised to the power of 0 is 1. So 1 minus 1 is 0. So we have e raised to the power of 0 multiplied by e raised to the power of 0 is 1 multiplied by 3 exponential 0. We have to delete this too. We'll later come to this. For more on this topic, you need to subscribe to this channel. Now, we say but e raised to the power of 0 is equal to 1. So we have our expected value of x to be equal to 1 multiplied by 3 multiplied by 1. Therefore, the expected value of x is equal to 3. So this becomes our mean for the first moment. This becomes our mean for the first moment. And we are also asked to find the first and second moment. So we're looking for the second moment now. We'll be looking for the second moment. For we to look for the second moment, we move over to this side of the board. For more on this topic, you need to subscribe to this channel. So the second moment, we've already found the first moment, which is the expected value of x to be equal to 3. Now we have to check for the second moment. That means the second derivative. We have to recall that our first moment gave us exponential 3 et minus 1 multiplied by 3 et. Now, to get our second moment, we have to take the second derivative of this. We have to take the second derivative of this. And for we to do that, we need to employ what is called the product rule of differentiation. So we say applying the product rule, applying the product rule of differentiation, applying the product rule of differentiation, we can write it as the y all over the t is equal to b v du all over the t plus u dv all over the t. So that is all we do. And now, if we have this, we see that the whole of this can be our u, while the whole of this can be our v. The whole of this can be our u, while the whole of this can be our v. Now, this we have written here is the same thing as our second moment, which is equal to the same thing, but y all over the t is equal to v. Now we bring down v. V is this. To bring down v, we write 3 t. Now we differentiate the u all over the t. The u all over the t. We have differentiated this before, and we got this. This is what we got. So we just write multiplied by exponential 3 et minus 1 multiplied by 3 et plus plus u. What is our u? U is the whole of this. So we have e 3 et minus 1. That's what we have. U multiplied by the v all over the t. If we differentiate this function, we get multiplied by 3 et. So if we differentiate this function, we get the same thing multiplied by 3 et. So we can write this out. It then means that our second moment is equal to 3 et multiplied by exponential 3 et minus 1 multiplied by 3 et plus exponential 3 et minus 1 multiplied by 3 et. So this is what we get. Now, the next thing to do, you now say, we'll rewrite this out properly. That means our second moment, rewriting it out properly, rewriting this out properly, we say our second moment, this can multiply this to give us 9 t 2t, this multiplied by this, multiplied by exponential 3 et minus 1 plus exponential 3 et minus 1 multiplied by 3 et. So this is what we get. Now, the next thing to do, we say to get the second moment, that is the expected value of x squared, we say at t equal to 0. At t equal to 0. So to get at t equal to 0, we will now move over to this other side of the board. Move over to this other side of the board to do that. For more on this topic, you need to subscribe to this channel. So we say at t is equal to 0. At t is equal to 0, anywhere we see t, we put 0. Our second moment will be equal to 9 exponential 2 multiplied by 0 multiplied by exponential 3 e raised to the power of 0 minus 1 plus exponential 3 e raised to the power of 0 minus 1 multiplied by 3 e raised to the power of 0. So this will give us 9 exponential 0 multiplied by exponential. This is 1, 1 minus 1 is 0, 0 multiplied by 3 is 0, plus exponential. This will give us 0 multiplied by 3 exponential 0. So the next thing to do, we say but exponential 0 is equal to 1. So we have our m t to be equal to, we have our expected value of x squared, which I have written before, which is equal to m, our second derivative is equal to, this is 1, so we have 9 multiplied by 1 multiplied by 1 plus 1, which is this, multiplied by 3 multiplied by 1. So it then means that our expected value of x squared is equal to 9 multiplied by 1 is 9 plus 1 multiplied by 3 is 3, which is equal to 12. So it then means that therefore our expected value of x squared is equal to 12. So the expected value of x is 3 and the expected value of x squared is 12. Now, the B part, if you can recall, in this question, asks us to find the variance of x. The variance of x for the given what? PDF. So for you to find the variance of x, we'll move over to this side of the board. So we'll have to clean that side of the board. For more on this topic, you need to subscribe to this channel. We have succeeded in finding the first and second moments. Now we are finding the variance. For more on this topic, you need to subscribe to this channel. So the B part, we have to find the variance. The variance of x is equal to the expected value of x squared minus the expected value of x all squared. So this is the formula for variance. For we to find the variance, we need to know what the expected value of x squared is and what the expected value of x is. Now, what do we need to do? We substitute the values, the variance of x. We substitute the values for expected value of x squared. What did we get as the expected value of x squared? We got 12. We got 12 as the expected value of x squared. And what did we get as the expected value of x? We got 3. So 3 is the expected value of x, and 12 is the expected value of x squared. So all we need to do is just to substitute whatever we have here into the variance. So we have expected value of x squared to be 12. So we have it as 12 minus the expected value of x is 3 all squared. So our variance of x is equal to 12 minus 3 multiplied by 3 is 9. That means that our variance of x is equal to 12 minus 9. 12 minus 9 is 3. So this becomes our variance. That becomes our variance. This is simply how to calculate the first and second moments of the moment generating function given the PDF. Now, we are asked to calculate to show that the probability of x is equal to 0. The probability of x is equal to 0. So to do that, we have to clean this other side of the board. To do that, we clean this other side of the board to take that question, the third question. For more on this topic, you need to subscribe to this channel. So we are asked to calculate C, the probability that x is equal to 0. If you watch out our question, and what are we given? We are given, we know we are given the moment generating function to be exponential 3 et minus 1. This is what we are given. So this matches the moment generating function of the Poisson distribution. This matches the moment generating function of the Poisson distribution. If you want to compare it with the moment generating function of the Poisson distribution, we can say the MGF of Poisson distribution is, we can write it as M to be equal to exponential. Now we put lambda here. Yes, this lambda, this becomes just et minus 1. So if we compare it, we see that x follows the Poisson distribution of lambda, which is x follows the Poisson distribution of, this is 3 when compared to this of 3. So it's very simple. How do we now compute what we have here? We can now say that the probability that x is equal to, okay, we should know that the probability, if we have something like this, is equal to exponential negative lambda, lambda raised to the power of k all over k factorial, all over k factorial. So if we have the probability of x is equal to 0, it then means that anywhere we see k, we put 0. We already have our value for lambda. We have our value, lambda is equal to 3. So we should take note of this. Now, we move over to this other side of the board. The probability of x to be equal to 0 is equal to exponential, like we have written, negative lambda, lambda raised to the power of k all over k factorial. Now, we substitute all the values we have. We substitute all the values we have. Where lambda is equal to 3, this lambda is equal to 3, and k is equal to 0. K is equal to 0 because if we have k here, this is k, this is k. So k is equal to 0. So we have our probability of x to be equal to 0 will be equal to exponential negative 3, then 3 raised to the power of 0 all over 0 factorial. So this will give us exponential negative 3 multiplied by anything raised to the power of 0 is 1 all over. What is the factorial of 0? The factorial of 0 is 1. We can also confirm that. The factorial of 0 is equal to 1. Is equal to 1. So it then means that therefore the probability of x is equal to 0 is equal to exponential negative 3. So this thing is exponential negative 3, which is the probability of x to be equal to 0. So this is how we have succeeded in computing the moment generating function of what was given to us in that question. So this is how we can compute the moment generating function of any given distribution, any given PDF, and how we can find the first and second moments of any given PDF. For more on this topic, you need to subscribe to this channel.